Okay, so we're going to get ready and take the data. We're going to turn on the testing machine, and the dial gauge is going to turn. We've got one camera on the dial. We've got another camera on the troptometer and the specimen. So right now it's in the stop position. We're going to turn this on and forward. Right now we're at 0. So we're going to mark our 0. It's our initial torque, and then we're going to increase the speed, and Christopher here is going to keep an eye on the dial gauge for me, and then I'll mark the testing dial. So to start this off, we don't want to go too fast, yet we want to get done.
Mark. 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 Mark.
We're close to 2,000 inch-pounds.
Mark. 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 Mark.
And now the spacings are getting a little closer together, so we're probably yielding.
Mark. 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 That's 200.
It's 200, okay. Now at 200, what we're going to do is we're going to unclip the wire from the wheel. Make sure you get the right screw. Okay, so we'll let that go, and then we're going to take a look at the degree measurement on the wheel. We'll zoom in on the degree measurement for a second. Okay, so you can see the degree measurement. We're approaching 20 degrees. Now in our lab report we say we should take a reading around 45 degrees. We don't need to look at the troptometer dial gauge anymore, so we're going to just frame it like this. And so kind of keep an eye, tell me when it's 90 degrees, or 45 degrees rather, and then I'll put another mark on it. I'm going to increase the speed a little bit. I'm about halfway on the speed indicator.
That's 45.
Next one's 90. The torque isn't really changing, but the degrees are changing quite a lot. A lot of plastic deformation.
90.
$180. That's the next one. Speed's a little past halfway.
All right, that's 180.
This specimen has twisted more than 180 degrees right now. Next one is 270. Increase the speed a little more. Load's dropping, so that means the specimen is breaking. Probably got a little crack in it, so we are going to slow this down and stop it. So I'll get a nice shot of the dial. There's different scales on this dial gauge, on this dial on this testing machine. We are using the one with the red scale, so a full division is 1,000 inch-pounds. And so, let me back out a little bit, from 0 to this mark is 1,000 inch-pounds, so you can get the gradations from there. Let me kind of zoom in. There's where we started on our 0, 10 thousandths, 20 thousandths, and I'm going to go around. You can pause the video if you need to look at it in more detail. Each mark is a 10,000th of an inch, and then we took the wire off, and then we started marking in degrees, and so these are the degree measurements, and we got a little bit beyond 360 degrees when it finally broke. I'm going to move that left side back out of the way. We can take our traptometer wheels off. Take our specimen out. A nice look at that fracture surface. It's a very flat fracture surface. This was a ductile steel. And there was a line that I drew on that before we started testing, and it's turned into a helical shape now. So that really twisted that metal right up. Very flat fracture surface, indicating that the maximum shearing stresses are straight up and down in our specimen. Ductile materials tend to fail because of high shearing stresses, and so we have that shaped fracture surface.